Hello and welcome. In this video we want to find the derivative of the function f of x equals x to the 3 using definition of derivative. If f of x equals x to the 3, find f prime of a. First, let me remind you the formulas that we can use for finding f prime of a. We can use this formula, f of x minus f of a over x minus a as x approaches a. This is one formula that we can use. The other formula is limit of f of a plus h minus f of a all over h when h approaches 0. You can use the first formula or the second formula for finding f prime of a. Here in this video, I'm going to use the first formula, this formula, for finding f prime of a. But, of course, you can use the other formula for finding f prime of a. So, let us start finding f prime of a. F prime of a would be limit of f of x. F of x is given x to the 3 minus f of a. For finding f of a, simply you have to replace x with a. So f of x is x to the 3. What is f of a? A to the 3. All over x minus a when x approaches a. For finding this limit, probably you know that you have to factor out numerator. To factor out numerator of this limit, if we know the difference of cubes identity, we can factor numerator. Otherwise, factoring numerator is a bit challenging. But later, I will show you a way that you can factor out numerator without knowing any identity at all. There is a way that you can factor numerator without any identity. But of course, if you know the difference of cubes identity, you can factor out numerator easier. The difference of cubes identity is this. A to the 3 minus b to the 3 can be factored in this way: a minus b times by a to the 2 plus ab plus b to the 2. Based on this identity, we can factor the numerator of this limit like this. It would be x minus a times x2 plus ax plus a to the 2. And in the denominator we have x minus a as x approaches a. As you can see, x minus a from numerator with x minus a from denominator, we can cancel these two. And then we have limit of x to the 2 plus ax plus a to the power of 2 when x approaches a. Now if we plug in a here and here for x, we have a to the power of 2 plus a times a is a to the 2 again. So we have a to the 2 plus a to the 2 plus a to the 2. It would be 3 a to the power of 2. So what is f prime of a? 3a to the 2. If you are familiar with the derivative rules, probably you know that derivative of x to the 3 is 3x to the 2. And if we plug in a for x, it would be 3a to the 2. That's the reason we got this answer. But here, the purpose of this video is to find f prime of a with the definition of derivative, not with derivative rules. Before I finish this video, let me tell you how we can factor numerator without any identity, because maybe you don't remember this identity. How we can find this limit without any identity? Let me rewrite the limit here again. We want to find limit of x to the 3 minus a to the 3 over x minus a as x approaches a. For finding limits, the first thing that usually we try for finding limits is direct substitution. If here we plug in a for x, the numerator would be a to the power of 3 minus a to the 3, it's 0, and denominator is also 0. But attention, when you substitute a for x in numerator and numerator equals 0, from this we can conclude something very important. But what is that thing? Let me repeat this again. Whenever you do direct substitution in a polynomial like this in the numerator, and after direct substitution, so whenever you plug in any number that is here, maybe x approaches a, maybe x approaches 2, maybe x approaches 0, maybe x approaches 5, when you plug in whatever this number is in the polynomial and you get 0 without any try, without any effort, you know one of the factors for that polynomial. What is that factor? X minus a. Let me review this again because it's very important and very helpful in finding limits. Let's say we have a limit and there is something in numerator, doesn't matter what is that, just a polynomial. Attention, it should be a polynomial, something like 2x to the 2 plus 5x something, x to the 3 minus 4x plus something, different degrees of x, polynomials. And let's say x approaches 5. If you plug in 5 in the numerator and the 5 makes numerator 0, which makes usually the numerator 0 in limits, usually when we try direct substitution we get 0. When you get 0 by direct substitution, this means that this polynomial, if you want to factor it, it has x minus 5 as a factor. Let's say x approaches 3, then this means that x minus 3 is the factor for this polynomial. If x approaches negative 2, then x plus 2, move negative 2 to the left, x plus 2 is the factor for your polynomial. Back to our question. Here x approaches a, and when I substitute a for x, numerator is 0. This means that x minus a is a factor for x to the 3 minus a to the 3. But the problem is that we don't know the bigger factor. If you remember, when we factored here x to the 3 minus a to the 3, we got this. But how we can find the other factor, which is a bit harder to find? Now that we have one of the factors of x to the 3 minus a to the 3, simply you can do long division for finding the other factor. You have to divide x to the 3 minus a to the 3 by x minus a to find the other factor. Or you can use synthetic division for finding the other factor. Let me show you how you can find the other factor with long division. And also I can show you how you can find the other factor with synthetic division. If you want to divide x to the 3 minus a to the 3 with x minus a, we start with dividing x to the 3 by x. X to the 3 divided by x is x to the 2. Then, as you know, in line division we multiply x to the 2 in all of these and we write it here. x to the 2 times x is x to the 3. X to the 2 times a is ax to the 2. Now we have to subtract these two from each other. If we subtract x to the 3 from x to the 3, x to the 3 and x to the 3 cancels. And if we subtract this from this is going to be positive. So it's going to be ax to the 2 minus a to the 3. Now we have to divide ax to the 2 by x. It would be ax. Now again, if we multiply ax by x minus a, it would be ax to the 2 minus a to the 2x. Subtract these two from each other, it would be a to the 2x minus a to the 3. Divide a to the 2x by x, it would be a to the 2. If you multiply, it would be a to the 2x minus a to the 3, and if you subtract, the remainder is 0. Now this is the other factor that we look for, x to the 2 plus ax plus a to the 2 over x minus a. X minus a and x minus a cancel each other, and so what remains would be x2 plus ax plus a2 as x approaches a. If you substitute a for x, it would be 3a to the 2. Attention, here the most important thing that you have to learn here from this new method is not the long division method. No, it's this, that if x approaches any number, if you want to factor numerator, one of the factors is always x minus a. This is what you have to learn from this new method. If x approaches 5, x minus 5 is a factor. If x approaches negative 7, x plus 7 is a factor for if you want to factor numerator. And let me show you how you can find this with the synthetic division. In the synthetic division, if you remember, now let me show you how we can find this with the synthetic division. If you want to divide x to the 3 minus a to the 3 by x minus a, attention, first of all, the coefficient of x to the 3 is 1. So we draw something like this: 1, 0, 0, and then negative a to the 3. The zeros here and here is because, attention, between x to the 3 and a to the 3 we expect usually to have x2 and x, but we don't have any x2 and any x. Why? Because the coefficient of them is 0, and as you know, in synthetic division we have to put the coefficient of x to the 2 and x in the process, in the process of synthetic division. We have to consider that. And because we want to divide it by x minus a, we have to put only a here. And if you remember, this drops here, 1 times a is a. We add these to a times a is a to the 2, 0 plus a to the 2 is a to the 2, a to the 2 times a is a to the 3. If you add negative a to the 3 and a to the 3, it would be 0. Now look at this. 1 is the coefficient of x to the 2. A is the coefficient of x, and a to the is the constant. Compare this with this, it's exactly the same. I hope you like this video, and see you in the next videos.